Hey guys, welcome back. In this video, I want to prove that the derivative of cotangent x is negative cosecant square x from the first principle. As we know that if we have y equals to f of x, here it is cotangent x, then derivative of y, which is f prime of x, from the first principle can be written as h tends to 0 f x plus h minus f of x all divided by h, right? And we know that this cotangent in terms of sine and cosine as cosine x upon sine x, right? By using this, we will get derivative of this function, which is cotangent x here, can be written as limit h tends to 0 cosine x plus h divided by sine x plus h minus cosine x upon sine x all divided by h here. And we have to recall the formula for cosine x plus h and sine x plus h as, so we will expand this expression by using these expressions and we will find the common denominator. Okay, so we will have limit h approaches to 0 cosine h cosine x minus sine h sine x divided by sine x cosine h plus cosine x sine h minus cosine x upon sine x all divided by h. And now we'll find the common denominator by multiplying this, okay? And we will get cosine h cosine x minus sine of h sine of x, okay, whole times sine of x, this sine, minus sine of x cosine of h plus cosine of x sine of h whole times cosine of x, this sine, divided by h times sine x times this one is just sine x plus h. Okay, and the limit is tends to 0. Now what we will do is we'll try to multiply this sine x to whole term and cosine x to whole term and try to group the like term and see whether some terms can be cancelled or not. Okay, by doing this we will get limit h tends to 0 sine x cosine h cosine x minus sine squared x sine h, right, minus cosine x sine x cosine h, this one the sign will distribute here, so it will be minus cosine squared x sine h divided by h sine x sine x plus h. And here we know that we can cancel some terms here. If you observe very carefully, this term and this term is completely same but with opposite signs, so we can cancel this term, okay? And we also have that this sine h and this sine h is common for this term, and by cancelling and grouping the like terms we will have limit h approaches to 0, this and this will go to 0, so we will have negative sine h as a common term, and we'll have sine square x plus cosine square x, because here is negative, so I have taken negative common term, divided by h sine x plus h and sine x. Okay, now here we have obtained this nice relation here, that this whole term is just equals to 1 from the Pythagorean identity. Now it will be limit h tends to 0 sin h upon h sin x plus h only here. And it seems that we can evaluate this limit right now, because we know that here this term will go straight to 1, and here this term, when x approaches to 0, will approach to sin x. Here we also have sin x. It will be negative 1 upon sin square x only, right? So it will be just negative 1 upon sin square x, which is negative cosecant square x. So we have successfully proved that the derivative of cotangent x is cosecant square x, and which will also imply that integral of cosecant x with respect to x will be negative cotangent x plus c. And this is also a very important result. I hope you have enjoyed this video and understood this proof, and I will see you in next video. Thank you.